Hello, this is Ms. DB. In this video, we're going to look at what happens when you have negative exponents, and then the very simple case of what happens if you have an exponent. So the negative exponents rules, there's a couple of them. The first one is if you have a number with a negative exponent, that's the same as 1 over that number to the positive value. So here's an example, 2 to the negative third is the same as 1 over 2 to the positive third. And that's the same as 1 over 8. And we usually would just leave our answer as 1 over 8, like that. Let's look at another example of that. Let's say we had x to the negative fifth. That's the same as 1 over x to the positive fifth. It also works the other way. If you have 1 over x to the negative fifth, with the negative exponent being in the denominator, that's equal to x to the positive fifth. Basically, when you move a base up or down in the numerator to the denominator or the other way around, it changes the sign of the exponent. The other part of this worksheet is going to deal with fractions that have negative exponents. So if you have a fraction like a over b and it's raised to a negative exponent, that's going to be equal to its reciprocal to the positive exponent. So if you have a over b to the negative n, that's the same as b over a to the positive n. And you can work out step by step why that is true, but it is true. And then you can use the next one of the previously learned properties to say, well, that's the same then as b to the nth over a to the nth, if you need to, or if you can simplify more from there. The zero exponent rule is really simple. It's any number to the 0 power is equal to 1. Whether it's a variable or a number to the 0 power, it's equal to 1. Even if you have lots of stuff to the 0 power, it's equal to 1. Like 5x to the 6th times 7x to the negative 4th. If it's to the 0 power, it's all equal to 1. So on this worksheet, we are going to write all with positive exponents. Those that are highlighted in yellow are solved in the Khan Academy videos. There's 3 of them, so you may have to search a bit to find them. The ones with stars out by them I'm going to do in this video. So the first one is number 1 is 4 to the negative third. The rule is I can write that as 1 over 4 to the third power. Now 4 to the third, that's kind of on the fence about being a really big number or not a big number. 4 to the third power we can find is not too big, it's 64. So this could be simplified to 1 over 64. That's not bad. We would not write that as a decimal. We would just leave it as 1 over 64. The answers for 2 and, well, number 2 as well. Don't write it as a decimal if it, I don't think it will be anyway. And number 3, of course, will be something with A's. Let's look at number 4, 5, 6. They're not too difficult. Let's look at number 7. Well, this isn't difficult either. We have x to the negative 20th over x to the 5th. The rule is if you have a negative exponent, you can move it down to the denominator to make it positive. So I'll have to put a 1 up here because I can't just leave it hanging in space. And then in the denominator already was an x to the 5th. It's not simplified if I have 2 of the same variables. So in the numerator, I just have 1. On the bottom, I have to use the rule that says if you're multiplying the same bases, you add their exponents. And you would leave your answer like that. Because we want all of our exponents to be positive. It is, so then that is left in the right form. Number 8, that's exactly like this example here, that says that you can take the reciprocal of the base raised to the opposite of the power. So 3/8 is our fraction. The reciprocal of that is 8 over 3. And then you can raise that to the opposite of negative 2 would be 2. And now you go ahead and write that as it's 2 parts. It'll be something to the second power over something to the second power. And then you can simplify a little bit further, because 8 to the second power and 3 to the second power are not that big, so you can write this as a fraction at the end. And then one more, maybe 2 more that we're going to look at, number 14 on your worksheet. we have x to the negative 5th over x to the negative 12th all to the 6th power. There's more than one way to do this but I'm going to first write this part, this fraction, with positive exponents, because I can bring x to the negative 5th down to make it be positive, and I can bring x to the negative 12th up to have a positive exponent. So basically you flip-flop them, and you'd have x to the positive 12th over x to the 5th raised to the 6th. And then I'm going to simplify this using the quotient rules that you did on your last worksheet. We have the same base, x and x. We can subtract their exponents. So x to the 12 minus 5 is 7, and that raised to the 6th power. So now we can use the rule that says when you take a power to a power, you multiply the exponents. So you definitely need to know the rules and properties from the last couple of worksheets in order to complete this worksheet. And when we're all done, we get x to the 42nd power. So it's often easier if you simplify what's in the parentheses first before raising it to the exponent. Oh, and it does look like I have one more star, number 16. So 16 is a good example of we want our x's by each other and our y's by each other in our number parts. We did one very similar to this on the last worksheet. So I'm going to leave the 25 over 5. They're already next to each other. There's no other coefficients. Let's put the x to the 1 over x to the 2nd. And then here we have a y to the negative 6. And on the bottom, y to the 5th. And that's really all over the same, that's one fraction bar, but you can break it into pieces if you want. Okay, 25 over 5, that's just 5. What about the x over x squared? If you want, you can put x to the 1, and you can subtract exponents. Or you can think to yourself, well, that means there's one x on top, and on the bottom there's x times x, so that means there's one x left, and it would be in the denominator. Now this part, y to the negative 6, we want to rewrite this. So that means if I bring it down, I would have a y to the positive 6th in the denominator, and I still have a y to the 5th in the denominator as well. So all together now I have 5 at the top, that's the only thing left on top. In the bottom we have an x to the 1 if you want. And then for y to the 6th times y to the 5th, the rule is if you multiply the same base, you have to add their exponents. So x to the 11th. And that now is as simple as you could write that. If you're typing these, make sure you use parentheses in as many places as you can. Like the answer for this would be 5 divided by, and then you'd have x, I guess I'll do x times y to the 11th. And then I would close my parentheses because I don't want it to look like the whole thing is to the 11th power. So, and that using parentheses shows that the denominator is that there. Make sure you show your work on these. That is required in this class. You can write your answers by hand and submit pictures, or you can type your work as you go if you prefer that. Let me know if you have any questions or if you want to work on this together. Come to my office or ASC hours. Thanks a lot. Have a great day.